Hello, this is my recording on Helm charts. In Kubernetes, you deploy objects. If you have an application, you'll have multiple objects like config map. You could have a pod, you could have secrets, you could have multiple config maps, you could have multiple containers running multiple pods, different pods, right? So all these would constitute your application. And in Kubernetes, the way you would deploy each of these objects is using manifest files, which are nothing but YAML files. So you may, for an application, you may have 5 to 6 manifest files, each creating a different object and in a given namespace. So that's Kubernetes. Now, Helm is a package manager for Kubernetes. When I say package, um, it is a grouping of all the manifest files that are needed for one given application. So the package may contain config maps, secrets, deployment objects, pods, whatever has to go into an application. The way Helms works is it would package all the manifest files, but there is a structure to it. So Helms adds some more features to the manifest files. Um, First of all, a Helm chart is per application. When you say a chart, Helm chart, it is actually it will deploy all the objects that are needed for a given application. The Helm chart itself would have a directory structure, and the directory structure is pretty much like this here. It'll have a package name, it'll have these directories, and we'll talk about what goes into each of those directories. At the minimum, the most important directory is the templates directory. Within the templates directory, you will have the manifests for all your objects. But there are more features to Helm than just manifest files. So, for example, you would write your manifest files in a as a template, and Helms offers you more some of the language add-ons to write those templates. Uh, for example, one of the good example is you could use variables that could be used to populate those templates. So what Helms would do is when you install a chart, it would take all the files, all the template files in the template directory, convert them into Kubernetes manifest files, and then run them against your Kubernetes cluster. So that's how it works. Takes the templates, renders them into manifest files, and then runs them against your Kubernetes cluster. Okay, so that's how Helm works, and that's the value add of Helm. It is giving you a lot of language features for writing your manifest files. Okay, so before we go any further, let's cover some of the basics, which is you can run Helm from anywhere, anywhere in the sense that anywhere should be able to connect to your Kubernetes cluster. It could be anywhere where you are able to connect to your Kubernetes cluster, because ultimately you are going to install your Helm chart, and for installing something, right, you need to connect to that Kubernetes cluster. So first and foremost, on that box, probably you would have to configure your config file so that you are able to talk to your cluster. You would install your Helm software using these steps here that you see. And once you have installed it, uh, there is nothing much. You basically have the CLI called Helm. After you have that, one of the things that you may want to do is you may want to um, uh, make a local copy of a repo. Now let's talk about repo. All the charts, all the packages exist in a repo, and these are remotely hosted. There are several repos out there, and those are publicly available that would host the repos. You could also host the repo on a on any repository, Helm repository that you would like. Uh, so the repos would exist there. One way to reach a specific chart would be to use the URL for that repo. But an easier way is to make a local copy of the repo. And when I say local copy, you're pretty much giving a user-friendly name to a remote repository. And the way you would do that is using the add command. Okay, Helm repo, and then add, and then give the URL for the repository wherever it exists. For example, if you take Argo CD, Argo CD Helm exists on a specific repo, that Argo CD would host it. Likewise, Terraform may host its own repo somewhere else, and so on and so forth. All you need to know is where is the repository, and then you would use an add, and you would give a local name, uh, and then uh, the pretty much when you say Helm, Helm repo add, and a local name and the URL, you're you're pretty much creating a reference for your a remote repository. Now, after you have created a local reference, when you do, you could use that local name for um, all the commands where you would try to access that chart. So for example, if you do, you could do a Helm repo list, and it'll list you all the local repositories. You could also search. Now that you have given a local name, Helm search repo, and then the repo name, it'll give you a listing of all the charts that exist in that repo. And then you could also reference any of the charts using the local name slash the chart name. And that's pretty much how you can reference any repository in your commands, which we will talk about in the next few minutes. Uh, the repo itself, it is a the chart itself is a gzip file with a specific structure, like we just talked about. It's got this structure. When you expand it, and we'll look at what all goes into each of these files. So the first file that we want to talk about is the chart.yaml. Every chart should have this file. All this file has is few key value pairs. The first one is the API version. You want to say whether it's Helm 2 or Helm 3. Very likely it's going to be V3 for API version. You would have to give a chart name. You would have to specify a version. This is your own defined version. But you have to use the SimWer, standard 0.1.1, 0.1.2, blah blah blah. And then you can give an app version also, and then a description. So these are pretty much the chart.yaml file is only telling you, giving a name for the chart, and the version for the chart, and the Helm version that it should use. Okay. Um, Also, along in the chart itself, you can also define if the chart itself is using some other dependencies, you can also specify those. Um, and when I say dependencies, there are like other charts that it would depend on. So whatever dependencies you depend on, uh, they would actually get downloaded into another directory, which we will talk a little later, or for that matter, it's going to install all those under the charts directory. So there is another directory called charts. So anything that you specify as dependency, it will deploy that chart under the charts directory. It will create a local copy. It will create a local copy. Okay. Now, the most important piece is the templates. Templates is where you will have one or more files that you use to create your manifest files. That's what it is. So you could write a complete manifest file without any template language, and that's fine. But if you want to make it feature rich, you could use some of the functions, variables that Helm offers. So anything that is template, anything that you want the template engine to render, you would put it in these two brackets here, okay? And and whatever commands you want to put in there, it will go there, okay? I will pause now. Okay, before we go into the features of template and the rendering, right? Let's look at some of the commands that you would use. Because this is where it'll pretty much go, right? So once you have your chart locally available, you could always use Helm install, okay? And then each chart has a chart name, but also you can give a release name, which is nothing but your own name that would exist in your Kubernetes cluster. So if you want to install a specific chart, Argo CD, you would say Helm install my Argo CD, and then you will give the chart name, and chart name would be your local repo name slash Argo CD. Now that would install everything, that would first render everything that's in the templates file. It'll use the values files and it'll create the manifest files and it'll install on your target Kubernetes cluster, right? Uh, so that's where the release name is. If you don't provide a release name, Helm would automatically create a random release name like Smiling Penguin or anything like that. But it has to have a release name, and that's how it would exist. Now, while you're running Helm command, you could always specify your kube context or your kube config file. If you have multiple Kubernetes clusters, you could always use those features, and you can also specify the namespace where it should go, and then it'll deploy. These are primarily used on where you should deploy your manifest files. Right, and then if you this is all for the install. Once you have installed, oh yeah, before you install, if you just wanted to see the generated manifest files, you could always do a debug and dry run option, and then it won't install it, but at least you will see the manifest files. Now, after you have installed your components, right, you can always use your kubectl, right? Oh, sorry, you could always check what charts have been installed. So if you do Helm ls, it will actually give you the list of charts that have been installed on your cluster. So you could always use Helm ls, and then you could always use, Helm status and the release name to get the status of the Helm chart. A very important command is Helm Get Manifest and the name of your Helm chart, Helm release. That will give you the manifest, how it got deployed. You could also delete the release. So these are some of the commands that you can use. Now let's talk about the template language, right? What one of the most frequently used feature of the template is a file called values.yaml. So values.yaml is nothing but a simple YAML file. It has key value pairs. It can have nested value key value pairs. Everything that you want it to be configurable in your manifest, right? You would specify that in your values file so that each deployment can use its own values. So all the end user has to use is change the values, and then uh, you know the the manifest, the objects are created as per the values that are specified in the values file. The values.yaml can also be overwritten during the install by specifying a specific YAML file, or by passing hyphen hyphen values, passing key value pair from the command line, uh, using the set option, and so on and so forth. But most frequently, you would just use the values file to make to create those values. So what happens after you create the values file? To the template engine, everything is an object. The the values is so templates engine. This is how it works. It has a namespace hierarchy. At the very top, there is a dot, the root hierarchy. And then template engine has some built-in objects. So some of the built-in objects are, for example, values. So it would be dot capital V values. So this object contains all the key value pairs from your values file in such a way that you could use this object if you want to use a value. So for example, if this is one good example here, if you want to, in your template file, you want to specify a value for drink, but it has to come from the values file. So this is how you would use it. What happens when you do it this way is that the value would be read from this values object, which is nothing but that file. So all the data that's in the values.yaml file become the contents of the values object. Okay, so that's a mapping. The second object is the charts. That's also another built-in object that automatically comes in with for you. That is all the components of your chart.yaml file, they become the key value pairs of the chart object. And the third object is release. So pretty much when you install your um, Helm chart, you give a release name, right? So that becomes the object. So you can always use uh, dot release dot name to get the release name. This is the most frequent object, at least the component of the object release that you would most frequently use, release dot name. Okay, now when you use those two flower brackets with the space, you can always use a hyphen to get rid of all the white spaces to the left or the white spaces towards the right. That is so that when you're rendering your manifest file, if there is a spacing that you want to get rid of, you can always use that, or if you want to keep the spacing, you can always do that, right? So those are some built-in objects that you can use. Besides those, you can also create your own objects. So those your own objects are called name templates, but they are your own objects. So the way you would create your own objects is within your template file, right? Or in a separate file that starts with an underscore. So the underscore file is pretty much only um, it's not going to be rendered, but it's going to be used by any other template file that you want to use. So the way you would define would be to use the word define and end, and anything that goes inside becomes that object, right? So this is how you would do your definition. And then once you have defined it, you can use it in your template or any template. Now, how you would use it, there are two ways. One is to use the um, use the action template. So when you use template and the name of the object that you have defined, it will install everything that is in that object. That's one way. The second way is to actually use a function called include. So even you could use include instead of using the template, right? You could use include and the name of the object. The advantage with using the function is that the output can be piped to another function or any function. One of the most common functions is going to be indent, which would let you indent this whole block, say by 2 spaces, right? Okay, let's talk about few functions. We talked about the include function already. There is a required function. You can always you would use a required function when you want to say a value has to be mandatory. So for example, you know, some you have to have a key value parameter which has to be mandatory. If you to make that, you will use that. Some of the advanced features are to use if else statement. You can use if else statement, with statement, and looping. They're all we'll cover in the next chapter. All right. Thank you.